is Introduction to Statistical Learning in R, Chapter 7, and we're in the applied questions. We're on question 10. Okay, so here's the questions here, and we'll look at them one at a time, but we're looking at the college data set here. Okay, so the first thing we need to do is to install the ISLR2 package and load it and get our data loaded up. And I'm just calling the college data set, I'm just calling it D. Okay, so for part A, we need to split the data into a training set and a test set. And so that's what's happening here. So I'm taking 80% of the data for training. Okay, so I say 80%. I calculate how many observations that is, and then I randomly sample from the number of rows in my data. I take train in number of observations, and then I index the ones that were sampled in the training index to be training, and the rest are called test. Okay, so there you go. And then using out-of-state tuition as the response variable, or out state, and the other variables as predictors, then we're going to perform stepwise selection on the training set, to identify a model, a satisfactory model. Okay, so there's different ways that you can do the forward selection. Here I'm using the leaps package. Okay, and here I go. Right, so I'm using the reg subsets. I specify that I want to do forward selection, and yeah. Okay, so now when I run this, I can select the best model based on different criteria. I can do the best adjusted R squared, or I can take the minimum CP or BIC values. Okay. Now, one thing I want to point out here is I think that probably what I do below this is going to be disconcordant with what happens here, because each time you run this, you're getting a slightly different training and test sample, and so I think that when I first ran this, it was a slightly different model than this one. But because it's too much work to go and re-specify everything in later models, I'm not going to change it. We're just going to pretend as though this all worked. To overcome that, I should have used set seed but I guess I kind of like to sometimes play with the variation. So okay. So now part B is we're going to fit a GAM, a generalized additive model, on the data, again using out-of-state tuition as the response, and the features selected in the previous step. Okay, so the features that were selected here. So and I'm going to use the 11th. I should be using the 11th model. Okay, so and I'm using BIC as the best BIC is what I'm using. Okay, so it turns out that the best BIC up here was 11, and this was model 11 here. So this actually should correspond, despite what I just said. Okay, so I'm installing the GAMS package, and here I'm using the command GAM, and I just go through and I structure the model like this. Notice that private doesn't have this, this bit around it. Okay, the reason is because private is it's not numerical; it's binary. It's one or not, so that doesn't play well with these additive models. Which, yeah. So anyway, so we do that, and then we can do a couple of things. So we can look at the summary output, and that's all of this here. Or we can plot it, and that's what we're supposed to do. And you can see the relationship between, let's zoom in here. You can see the relationship between each variable with the outcome. Okay. Let's see. Okay, so we plot and explain our findings. So we just looked at the plot, but the way that we can kind of harness this summary output is this first one talks about significant linear effects of each of the variables, of which looks like all of them have, which I guess we should expect from the forward selection process. And then the second one speaks to strong evidence for nonlinear relationships, of which it looks like there's one for acceptance, maybe a few others. Okay. So now we're supposed to evaluate the model obtained in the test set and explain the results. So I'm not really sure how to evaluate it, but I'm going to use adjusted R squared. And so you can just kind of see the math that I used to do that. But the adjusted R squared is here. Okay, good enough. And then finally, part D is for which variables, if any, is there evidence of a nonlinear relationship. Well, we already looked at that when we just talked about it. So we looked at the summary for that GAM here, and I just put it in an object called GAM sum, and we get that information here. So on this particular run, again, accept, personal, expend, have a nonlinear, or there's strong evidence for a nonlinear relationship between those variables and the outcome. Okay, call that good.